looking at the chemical properties of alkyl halide or haloalkanes. That's talking about the reactions, okay? Now, the first chemical property we'll talk about, is hydrolysis. Of alkyl halide, okay? Of alkyl halide. Now, in the hydrolysis of alkyl halide, we can hydrolyze it using either water, an alkali, or silver hydroxide. Okay, so this hydrolysis simply means that if you are reacting it with water, H2O, this reaction will lead to the formation of an alcohol plus HX, right? So what happened here is simple. This is a nucleophilic substitution reaction where the water splits. You know how the water splits to give you OH and H. So the OH will replace the X. The nucleophile in the water, will replace the X, which is the OH group, right? This. So we have the H. So this H picks up this to have this. So this is just a simple way to explain this. Okay? Now, the other hydrolysis can be alkaline hydrolysis. Okay? If you use sodium hydroxide. This first one is a slow process, okay? This is very fast. This one is faster than this. Look at the kinetics of this reaction. So for this hydrolysis, you end up having the same alcohol, but this time around you have NaX, right? Then if you also hydrolyze it using silver oxide dissolved in the presence of silver oxide dissolved in water, this one will give you ROH plus what? AgX. So these are the several hydrolysis processes that happens in haloalkane to yield the corresponding alcohol and these byproducts you are seeing here. So this one is simply what we call hydrolysis of alkyl halide. Number 2, we look at Williamson ether synthesis. Okay, so the reaction of alcohol leads to what we call the Williamson ether synthesis. So this is a reaction of an alkyl halide with what? An alkoxide. Okay, an alkoxide could be sodium alkoxide or potassium alkoxide. So when you treat it with this, so you are going to have ROR plus NaX. Okay, for the sake of clarity, we can use prime to represent this, so we can show this is prime. Okay, so this is your ether, this is sodium halide. So these reactions, for example, if I want to use any alkyl halide, I can use CH3 CH2Br plus any alkoxide. Let's use sodium methoxide, for example. So what you are going to have is simply you have CH3O. So this alkyl group comes here. You have CH2 CH3 plus sodium bromide. So the same thing goes to this. So to these reactions you are seeing here, you can also use examples to represent them. So talking about hydrolysis of alkyl halide, we have this. Talking about the William ether synthesis, we also have this. So the next reaction will be dehydrohalogenation. Okay, dehydrohalogenation reaction. So this is simply removing of a hydrohalide, removal of what? HX. This is simply called removal of HX. Okay, so when you remove a hydrohalide from a haloalkane, you will definitely have an alkane. So this reaction, if you have an alkyl halide, and you are undergoing dehydrohalogenation, okay? If you undergo dehydrohalogenation of this alkyl halide, what you have here is an alkane, okay? So this is an elimination reaction. It's an elimination reaction that involves the removal of HX, okay? So for example, if I have something like CH3 CH2Br and you have The reagent needed for this elimination, the dehydrohalonation process, is carried out in alcoholic alkali, that is dissolving, having a solution of potassium hydroxide or any alkali, sodium hydroxide, in an alcohol such as ethanol or any alcohol, ethanol most times. So when you have this solution and you pass it through this guy, it will dehydrate, it will dehydrohalonate, that is removal of what? HBr. So bromine will leave from here and hydrogen will leave from here. So you're going to have CH2 double bond CH2. So dehydrohalogenation of ethyl bromide will produce ethane. So remember what I told you about the Sazef rule. The Sazef rule, this rule called Sazef rule. So Sazef rule comes into play if the alkyl halide is a secondary alkyl halide. For example, if I have CH3, CH2, CHBr, CH3. So if you're undergoing this same reaction using potassium hydroxide in ethanol as a case study, this dehydrohalogenation will occur, the Br will leave, then the hydrogen will leave from the side that has more alkyl group. So this side and this side, who has more alkyl group? What is here is ethyl, what is here is methyl. So the hydrogen will come from the side that has more alkyl group, and that is what we call the Sazef rule, okay? So if you're going to remove hydrogen from here instead of removing from here, so you're going to have CH3, CH double bond, CH, CH3. So the hydrohalogenation of this compound here is 2-bromo, 1, 2, 3, 4, butane, okay? This compound is 2-bromobutane, or some persons can call it isobutyl bromide, okay? Isobutyl bromide. So if you dehydrohalogenate this guy, you are going to have but2N. This guy will give you but2N, or you can say what? 2-butane. So this is a simple reaction involving the haloalkane and the what? Alcoholic solution of an alkali to give you this. Reaction number 4, Watts reaction. Okay, Watts reaction. Now this reaction involves the reaction of an alkyl halide with a sodium metal. Okay, it involves the reaction of sodium of an alkyl halide with a sodium metal. This reaction leads to the formation of an alkane. The end product of this reaction is an alkane. The main product is an alkane. So in the Watts reaction, this equation actually explains the Watts reaction. If I have something like this, sodium to give us 2 moles of sodium here, to give us the alkane, which is this, plus the sodium halide. So balancing the equation, you put 2 here. So this is the general equation for the Watts reaction, okay? So it's a balanced equation already. So why is it 2? I have 2 sodium here, I have 2x here, and I also have 2x here. So in this reaction, the alkyl halide reacts in a chain reaction to produce this. So example, if I have something like, let's use CH3Br as a case study, we are reacting with sodium. So this reaction will produce methyl group here will react with itself. It just like it will form, 2 of it will come together to have this plus 2NaBr. So this compound here is called ethane. Ethane is produced from methyl bromide, okay? It's produced from methyl bromide to produce this, okay? So this is what we call the Watts reaction, okay? The next reaction I'll talk about is reaction with cyanide, okay? Reaction with cyanide, okay? So this reaction forms what we call, this reaction leads to the formation of what we call nitrides, okay? It leads to the formation of what we call a nitride. So how do we get this nitrides? From the reaction of haloalkane with cyanide. So for example, if you have an ROX reacting with hydrogen cyanide as a case study, this reaction will lead to the formation of this class of compound called nitride. This will call nitrile, okay? Nitrile. So plus X will go with the hydrogen here to form HX, okay? So if this, remember that this reaction, ROX reacts with HCN to form the nitrile. So these nitriles, if you undergo hydrolysis of this nitrile, you are going to get alkanoic acid plus ammonia. The ammonia will be given off, okay? Ammonia gas will be given off. So this is hydrolysis, okay? Hydrolysis. Hydrolysis of this guy gives you this. So when you further undergo reduction of this guy, remember, reduction can be done using the reducing agents such as lithium aluminum hydride. So this reduction will give us a primary alcohol. So at the end of the day, we have a 1 degree alcohol. So the reaction is simple. This reaction, watch, from the reaction with cyanide, it forms a nitrile, okay? This nitriles on further hydrolysis will gives you alkanoic acid. And this alkanoic acid upon reduction will give you an alcohol. So this is the reaction involving haloalkane. So remember, this is the 5th reaction we are doing so far, and we are going to look at more reaction, okay? Formation of Grignard, okay? Formation of Grignard. So these alkyl halides are used in the formation of Grignard reagent. They are used in the formation of Grignard reagent, okay? So when you react this RX with magnesium in the presence of dry ether, you're going to have RMGX. That's a simple way. So if you have, let's say, CH3Br plus magnesium in the presence of dry ether, you're going to have methyl magnesium bromide. Okay, that's a simple reaction involving formation of Grignard using ether, using an alkyl halide, magnesium, and in the presence of a dry ether. So these are the few reactions you have to look into and understand very fast in case you are being asked to represent any of these things or discuss any of them in your exams.